Are aliens real?
They're real, but I haven't seen them, and they're not being kept in what is it?
Area 51?
Area 51. There's no underground.
For years, scientists believed they had the universe mostly figured out. Then NASA started analyzing the data and realized something doesn't add up. The latest images from the James Webb Space Telescope have revealed something that honestly shouldn't exist. Scientists were expecting to see tiny, messy galaxies in the early universe. Instead, Webb spotted massive, well-formed galaxies appearing only a few 100 million years after everything supposedly began. These aren't baby galaxies, still figuring themselves out. Some already look organized, mature, and surprisingly large. Here's everything we know so far. James Webb just flipped everything upside down. Let's start with the obvious. The James Webb Space Telescope was supposed to help us refine what we already knew about the universe. Instead, it's doing the opposite. It's forcing scientists to question almost everything. Every new batch of images seems to reveal something unexpected. Galaxies showing up way too early, structures forming way too fast, patterns appearing where there should be randomness. It's like the universe looked at our rulebook and said, yeah, no. Researchers are now openly admitting that many of our long-held assumptions might be wrong. Dark matter, dark energy, even the timeline of how the universe formed, all of it is suddenly up for debate. What makes this even crazier is that Webb isn't hunting for weird stuff, it's just doing its job. It's looking deeper into space and further back in time than any telescope ever has. And every time it does, it uncovers something that doesn't fit. Scientists like to say they let the universe tell them how it works. Right now, the universe seems to be saying it's way more complicated than we imagined. And this is only the beginning. The galaxy rotation problem nobody can explain. Here's where things start getting strange. For decades, scientists noticed something odd about galaxies. Stars on the outer edges were moving just as fast as stars near the center. That shouldn't happen. Gravity gets weaker with distance, so those outer stars should be flying off into space, but they don't. To explain this, scientists came up with dark matter, an invisible substance that adds extra gravity and keeps galaxies together. It became one of the pillars of modern cosmology. Now, Webb is complicating that story. The new observations suggest galaxies formed faster and grew bigger than dark matter models allow. Some of them look fully developed shockingly early in cosmic history. That shouldn't be possible if dark matter works the way we think it does. So now researchers are stuck with two uncomfortable options. Either dark matter behaves in ways we don't understand, or something entirely different is controlling galaxy formation. Neither option is comforting. What was once considered settled science is now back on the table, and the deeper Webb looks, the harder it becomes to defend the old explanations. Galaxies showing up way too early. This might be one of the biggest surprises of all. Webb is finding massive, well-formed galaxies from a time when the universe was supposed to be basically a newborn. We're talking just a couple 100 million years after everything supposedly began. These aren't tiny, messy proto-galaxies either. Some look organized, some contain older stars. A few are even comparable in size to the Milky Way. According to standard models, galaxies should need billions of years to reach that level of maturity. Yet here they are, showing up almost immediately. It's like discovering skyscrapers in a town that was supposed to still be laying its first bricks. This creates a massive problem. Dark matter was supposed to slowly pull material together over long periods of time, but Webb is seeing advanced galaxies before that process should even be possible. Scientists are now scrambling to explain how so much structure appeared so fast. Either galaxy formation works very differently than we thought, or the early universe wasn't as simple as our models claim. Either way, something big is missing from the picture. Why the universe isn't clumping the way it should now. Let's talk about something called the S8 tension. Don't worry, it sounds more technical than it really is. Basically, S8 measures how clumpy matter is across the universe. Using data from the early universe, scientists predict one level of clumping. When they observe today's universe, they get a different number. And the mismatch isn't random, it's consistent, persistent, statistically real. That's a problem. If our models were correct, both measurements should agree, but they don't. Which means either our observations are flawed, or something unknown is influencing how cosmic structures form. Webb is adding fuel to this fire by showing unexpected arrangements of galaxies and clusters. The large-scale structure of the universe doesn't look the way simulations predicted. This suggests that matter evolved differently over time than we assumed. Some researchers think new physics might be involved. Others suspect dark matter behaves differently on large scales. Either way, this tension hints that our current understanding of cosmic growth is incomplete. And again, Webb keeps making that gap harder to ignore. The expansion of the universe doesn't add up. Next comes the Hubble tension, which is another growing headache for cosmologists. When scientists measure how fast the universe is expanding using early universe data, they get one answer. When they measure it using nearby galaxies and supernovae, they get a totally different one. Both methods are solid. Both have been checked repeatedly, yet they disagree. That shouldn't happen. This has led to serious doubts about dark energy, the mysterious force believed to drive cosmic expansion. Some new observations even suggest dark energy might not be constant at all. It could be changing over time. If that's true, it breaks one of the core assumptions of modern cosmology. Webb's precise measurements are sharpening this conflict, not resolving it. The more accurate the data becomes, the clearer it is that something fundamental doesn't line up. Scientists are now openly discussing whether our entire framework for understanding expansion needs revision, and that's a massive deal. What if the cosmic microwave background isn't what we think? For decades, the cosmic microwave background has been treated as smoking gun evidence of the Big Bang. It's supposed to be the leftover glow from the universe's earliest moments, but new research is raising eyebrows. Some scientists now suggest that part of this radiation might come from early galaxies instead. Massive clusters of young, hot stars could have filled space with light that slowly stretched over billions of years until it looks exactly like the background radiation we see today. If that's even partially true, it changes everything. It means the CMB might not be a pure snapshot of the Big Bang after all. It could be contaminated by later cosmic activity. Even a small contribution from galaxies could affect how we interpret the age, size, and evolution of the universe. In extreme scenarios, it could weaken one of the strongest pillars supporting the Big Bang model. That doesn't automatically kill the theory, but it definitely makes things far more complicated. Why are so many galaxies spinning the same way? Here's another weird one. Webb analyzed tens of thousands of galaxies and found something unexpected. Most of them appear to rotate in the same general direction. That shouldn't happen. If the universe formed chaotically, galaxy spins should be random, about half one way, half the other. But that's not what Webb sees. Even stranger, the further back in time scientists look, the stronger this alignment becomes. Early galaxies were even more synchronized. Some researchers think this could mean the universe itself started with a kind of rotation. That idea doesn't exist in standard cosmology. If confirmed, it suggests the universe had an initial spin, which opens the door to entirely new theories about its origin. At the very least, it's another sign that something deep and fundamental is being overlooked. Could the entire universe be inside a black hole? And finally, we reach the wildest idea of all. Some physicists now propose that our universe might actually exist inside a black hole formed in a larger parent universe. Instead of everything beginning from a singular point, this theory suggests a massive gravitational collapse created a bounce that sparked our expanding cosmos. In this view, the edge of our universe would be equivalent to a black hole's event horizon. That means we can never see beyond it. This idea also fits with cyclic universe models, where universes are born, expand, fade, and give rise to new ones in an endless loop. It sounds crazy, but mathematically it works surprisingly well, and Webb's discoveries are giving these alternative models more attention than ever before. What once sounded like science fiction is now being discussed seriously in physics journals, which tells you everything about how strange things have become. If galaxies could form this early, does it mean our theories are broken, or are we standing on the edge of a completely new understanding of reality? Drop your thoughts in the comments. See you in the next one.